Here we have a question. In this question, we have to find the components of velocity and acceleration in y direction when the distance in x direction is given to us, which is 5 meter. As we can see, the path follows y direction in terms of x, which is written as y equal to 0.05 x square. So here in the question, we are given the velocity of the block in x direction. Also, we are given the acceleration of the block in x direction. Now, as we can see, the y direction position depends upon the distance traveled in x direction. So from here, we can get a relation for velocity in y direction in terms of velocity in x direction and distance x. And also we can get acceleration in y direction in terms of velocity in x direction, acceleration in x direction and distance x by differentiating this function, as you can see here. First of all, we'll differentiate it with respect to t. Before that, we'll take the normal differentiation. As we can see, we can write y dash equal to 0.05 multiplied with 2 into x multiplied with dx by dt. Here dx by dt represents the velocity of the block in x direction, which is vx. And we'll do the same for finding acceleration in y direction. We will differentiate this function in terms of t. So now let's move forward. Let's see what's given to us. As per the given data, we can see that the path equation is given to us where we can write y equal to 0.05 x square, and the x component of velocity is given to us, which is x dash, which is minus 3 meter per second. This negative sign indicates that the particle is having in velocity in x direction towards left, and the x component of acceleration is given to us, which is 1.5 meter per second square. It also denotes that this particle is having acceleration in minus x direction in x direction. So now let's move forward. Here, as we can see, we can write the path equation. We'll name it as equation number 1. Now let's take the differentiation. In order to find Vy, we can write dy by dt. We'll name it as equation number 2. And for acceleration, we can write Ay equal to dvy by dt. As we differentiate velocity in y direction with respect to time. Now let's substitute the values. First of all, let's find Vy, which is the differentiation of y component with time t. So as we substitute the value of y at 0.05 x square, we can find that dv by dv comes out to be 0.1 x into x dash. X dash represents the velocity of particle in x direction. So as we substitute the values, we can find the value of Vy that comes out to be minus of 1.5 meter per second. Now let's move forward where we have to calculate the values of acceleration in y direction. So before that, we will differentiate Vy with respect to time t. So let's differentiate Vy. As we know, the value of Vy is 0.1 into x into Vx. And we are going to differentiate it. So here, as we differentiate it, first of all, we will take differentiation of x, which is x dash, and we will keep constant Vx. And after that, we will take differentiation of Vx and keep x as constant. So from here, as we know, we can get this relation, and after that, as we substitute the values, we can find Ay is equal to 0.1 into Vx square plus 0.1 into x into Ax, where Vx dash represents the velocity acceleration of particle in x direction. So from here we substitute the value, Ay comes out to be 0.15 meter per second square. So we can say that the component of velocity when the distance x is given to us as 5 meter, it comes out to be 1.5 meter per second, and the y component of acceleration when the distance x as 5 meter is given to us, it comes out to be 0.15 meter per second square. Thank you.